Bismillah, Assalamualaikum warahmatullahi wabarakatuh. In this tutorial today, we will be dealing with moment of inertia. And this illustration here right now, it illustrates one of the example of the significance of the concept of moment of inertia. Now, this illustration just now, I actually take from the channel The Efficient Engineer, where they have one video on the moment of inertia basically. So go and take a look at that channel and that video, because I think they provide a great illustration on enabling us to understand certain concept, right? So take a look at that channel. I highly recommend it. This is not a paid advertisement or something like that. I just find that channel to be very helpful if you want to understand certain concept, because they have great way of illustrating the concept, right? Anyway, so as usual, the tutorial will cover example from the past exam questions, and we will take a look at how to address those questions. And if you need to take a look at that questions, the PDF is in the description box below. Take a look and you can straight away jump to any question that you like to watch, right, in terms of the tutorial or the how to solve the question, right? So in dealing with moment of inertia, we have two possible way of solving, just like in dealing with centroid, center of mass, and center of gravity. We can, or we might need to use integration, or we can actually use composite area or composite bodies, right? Just like in chapter 9, right? So for tutorial today, we will focus on the question that require us to do some integration, right? So without further ado, let's go to the first question. Okay, this is question number 1. So we have on the left there the diagram. So there are two curves making an area between them. So the question says, determine the moment of inertia about x-axis for the shaded area shown in the figure. Clearly specify which element is used in your calculation, right? So in terms of integration, the first step is you have to define which is your element, right? Whether it's horizontal or vertical. So based on that element, you have the equation that you can use, and there's a certain way to integrate the area, right? So in this case, normally the conventional or the original equation is based on, if you want to integrate for Ix, let me write here, right? So if you want to do for Ix, if you want to use the integration of y squared dA, this is valid for a horizontal element, right? So if you want to use a vertical element, then you cannot use this equation. So we will begin with this one first, solving using a horizontal element, use that equation, and afterwards we will also see how to solve using vertical element, and because it will be longer, so there's no point of using that in the exam, but just for understanding, we will cover that one as well, right? So first and foremost, all right, so after we have determined this one, so we have two curves here. So if you select this element here right now, so there's two curves, so let me select a different color. So in this case, if I say this is curve number 2, this is curve number 1, right? So that we will have 2 minus 1 in this case, right? Because what is the area? This one will be dy, this one is x2 minus x1, the length, right? So that's why I label this one is 2, 1, so x2 minus x1, right? To tally that. All right, so in terms of the curve, so this is y equal to 1/8 x square, right? So this one is y square equal to 8 x, sorry, y square equal to x, that curve, right? So when you do use this element, so you will integrate from here until here, right? Because the way you chop the element is from, this is the first element, and then that will be the last element. So that will be from 0 to 2. That will be your limit, right? So how to express this? Because we want in terms of x and x, right? So in this case, x1 is simply, obviously, is just y square. What about x2? So in this case, x2 is, you have to square root of 8y, right? So you'll have 8 power of half, y power of half, right? So it's basically, that is basically square root of 8y, right? So why I have a habit of straightway separating the square root, so that you do not, or you will have less likely to make a mistake in terms of calculation afterwards, right? So make sure to split the square root or something from the beginning, right? Otherwise you might forget. Okay, so based on that, so because we have dA here, right? So dA is just basically the base times the height. So x2 minus x1 times dy, right? So plug in all the values here. So x2 is 8 power of half, y power of half, and then minus x1 is y square, then dy, right? So this whole thing, or if you can put the bracket there, right? So plug in the a into this equation here. So Ix is integration from the limit of 0 to 2, and then y square multiplied by this whole thing, which is dA, right? So 8y 1 over 2, 1 over 2 there, 1 over 2 there, minus y square dy. So based on this, you just expand this, so you'll get integration from 0 to 2. So this will become y power of half, and then 8 power of half, sorry, y power of 5 over 2, right? Minus, so y square, y power of 4 dy. So integrating this, this is a constant. Then integrating this, y to the power of 7 over 2. So you have 2 over 7 over here. And then minus y to the power of 5. So over 5. So this whole thing, the limit is from 0 to 2. We don't have enough space, is it? Can you still see the, in terms of the lighting? Right. So down here, so if you plug in the values, you'll get basically 8 power of half times 2 over 7 times 2 to the power of 7 over 2 minus 2 to the power of 5, and then divide by 5. So if you calculate this one, you get 96 over 35 meter to the power of 4. Right, that will be your answer. Or if you transform into a number, so that will become 2.74. 2.743 meter, right? Meter to the power of 4. Okay, hopefully you can see this number. Okay, right, so that will be the answer. It's quite short and simple, basically. Just select the element, we take the horizontal, then we know this is the equation. So we need dA, so obviously this base multiplied by this, and then we know, okay, we need x2 and x1, so express x2 and x1, plug in, you get the dA, plug in dA into the equation, you get integration of y squared times dA, expand this, ready to integrate, and then plug in the number, and then you get the answer. Alright, so that is if you use horizontal element, right? What about if you choose to use vertical element? Now, so in the purpose of exam, normally there's no reason why you want to do this, except if the lecturer at that semester choose to be the evil lecturer and give you instruction, use a vertical element to solve this question. If the question in the exam says use vertical, then you cannot use this one. You have to use vertical, and then you will see after this why that lecturer is quite evil if you have to do that. Alright, so let's take a look at that. So let's store this value first so that we can check, right? So the answer should be the same regardless of which element you use. So the answer is 2.74 meter to the power 4, or in other words 96.35, right? So that's basically the same value in terms of decimal point or fraction, right? So we have, okay, all right, still for the same question, but if we want to use a vertical element, right? So if using vertical element, right? So for a vertical element, if you want to use for calculating for Ix, moment of inertia about x-axis, so the equation will be something, it will be basically this, integration of dix. So you have to establish first what is dix, right? That is where you have to use parallel axis theorem, right? So first and foremost, so we have to imagine this one first. So because this will be the element, right? Okay, so based on that, if we are to draw, so let me use, so the element will be something like this, right? First imagine this is B and this is H, right? And then the axis is here, x-axis, right? So parallel axis theorem states what? Parallel axis theorem, Ix equal to Ix prime plus A dy square, right? So we have learned this in the lecture video, so hopefully you have done watching the lecture video first before coming to the tutorial, because we have explained all of this, right? So what is parallel axis theorem and how to derive, right? So Ix prime basically will be, for rectangular shape like this, is 1 over 12 bh cube, right? That's basically the moment of inertia about its own centroid axis, right? So basically, if this is x prime, so Ix prime is that one, right? So plus A is basically just B times H. It's a rectangular, right? Dy is interesting. Why? Because we need to find out what is this, which is dy, right? The distance between the two axes, the two parallel axes, right? So we know that this is y1 and this is y2, right? Because if we label this as 1 and 2, right? So this is y1, this is y2. So the difference will be, basically, if this is 0, this dy will be just the average between y2 and y1, right? It's basically at the middle point between the two points, right? So basically we can put it as y2 plus y1 over 2, then square, because that's square there, right? So that's the average between y2 and y1. That's basically distance dy, right? So that's two ways of determining dy in this case, right? It will get you to this value anyway, right? So either you use average or you use y1 plus half of the difference, right? So it will go back to that value. We have covered that in the lecture, insyaAllah, right? Okay, so based on this, what is dix then for differential element, right? So differential element, because this is dx, right? So B will become dx, correct? H will become what? H is simply just the difference between y2 and y1, so it becomes y2 minus y1. So when we plug in here, what we will have in the end is, for this part here, 1 over 12, B becomes dx. H cube becomes this expression cube, right? So you'll get y2 minus y1 cube, and then you have dx, right? 1 over 12 bh cube. And then for this one, plus, okay, B is of course dx. H is y2 minus y1, right? So if we re-express this one, so y2 minus y1, and then you have y2 plus y1 over 2 square, and then you have dx, which is B, right? So you have this expression now, and you have to integrate this thing basically, right, with respect to x. So first, in that case, we have to resolve all of this first, right, so that we can get the expression that we can integrate, right? So that is the interesting part if you want to use this element for this question, right? So what do you want to do? Okay, expanding this one, right? So you'll have 1 over 12 outside. So basically you'll have y2 minus y1, and then we expand this one first. So y2 square minus 2 y1 y2 plus y2 square, right? And then dx, right? And then plus, okay, we'll do what? We'll take 1 over 2 outside, right? So because there's square, so become 1 over 4. we take outside, right? So now inside, so we'll still have y2 minus y1, and then you'll have y2 square plus 2y1 y2 plus y1 square, and then dx. Right, now we have to expand furthermore. Right, so 1/12 outside. So we have a long thing here. So we multiply both by y2 here, right? So it becomes y2 cube, and then 2y1 y2 square plus y2. Wait, what is wrong here? This is y1, right? Okay, is there any mistake? Right, okay, so again y2 with this one is y1 square y2, and then multiply everything with minus y1, so it becomes minus y1 y2 square becomes plus 2y1 square y2 become negative y1 cube, and then dx. Is it still there? Can you see? Is it already going into the light? Hopefully you can still see there. What about this one? Okay, 1/4 here, to make it simple, I'll just convert into something similar here, so it becomes 3/12, right? For 1/4 is 3/12, right? Okay, so that when we want to calculate after this, it is quite straightforward. So okay, this multiply by this one, right? So I'll multiply by y2 first, everything, so it becomes y2 cube plus 2y1 y2 square, this one, plus y1 square y2, so negative y1, so it becomes negative y1 y2 square, negative 2 y1 square y2, negative y1 cube, and then dx. Again, is it in the light? Right. Okay, based on that, I'll change the color now. So basically, alright, what do we have? We have, just to make sure we have all the expressions, so we have y2 cube there, and then we have this y1 y2 square, and then you have y1 square y2. This one is still the same thing here, this one is still the same thing here, this one is y1 cube, right? Alright, so let's calculate. So for y2 square, we have 1/12 plus 3/12 becomes 4/12, right? Okay, we'll let it be like that first, and then y1 y2 square, so it's basically this one, and this one, and this one, right? So this is negative 2, negative 1 becomes negative 3. Multiply here becomes negative 3, right? Here we have 2 minus 1 becomes 1. Multiply by here becomes plus 3. Plus 3 minus 3 is plus 0 here, right? Okay, next y1 square y2. So this one, and this one, and this one. So y1 square y2 plus 2y1 becomes 3, right? 3. This one, 1 minus 1 becomes negative 1. Multiply here becomes negative 3, right? So 3, negative 3 plus 0 here as well. Here we have minus 1 becomes minus 1. This minus 1 becomes minus 3. Minus 1 minus 3 becomes minus 4. So minus 4/12. Alright. So based on this, we can express what is dix. Now everything here is just to express here, so that we can plug in here later on, right? So based on this, okay, I missed something, right? So we have to put, because everything here and then dx here, right? Because what we are calculating here is just in the bracket here, right? And this, so dx is still there. Okay, so meaning dix equal to, for this one, 4/12 is 1/3, right? So 1/3 y2 cube And then here becomes minus 1 over 3 y1 cube. Minus 1 over 3 y1 cube. And then you have dx. Okay, that is the expression that we will use to plug in here, so that we can do the integration, right? Okay, so I think I can erase this part so that we can just plug in there into this one, right? Okay, so when we do use vertical element here, meaning that the first element is here for 0, the last element will be here, which is 4 in this question, right? So plug in there here, obviously we have to change y into x because we have to integrate with respect to x, right? So y1 here, what is the equation? So y here is 1 over 8 x square. Here y square is x, so y equal to x power of half, 1 over 2, right? So if you plug in, so x integration from 0 to 4, there are x, so the whole thing there, so 1 over 3 y2 square, so this one square becomes cube, y2 cube, this one cube becomes x power of 3 over 2, right? Minus 1 over 3 y1 cube, this whole thing cube, so 1 over 8 cube x power of 6, and then you have dx, right? So integrate, so integrate becomes 1 over 3, this becomes x 5 over 2, so 2 over 5 here, minus 1 over 3 1 over 8 power of 3 x power of 7 over 7. So the limit is from 0 to 4. So plug in the value, so if this simplified becomes 2 out of 15, and then you have 4 to the power of 5 over 2, and then minus 1 over 3, I'm not sure, this you can use your calculator, but for now I just leave it there. So this becomes 4 to the power of 7 over 7. Right, so if you calculate this, let me check, so it should be the same, right? 2, 5, 4, 5 over 2, minus 1, 8, 3, 4 to the power of 7, 7, right? So it should give you 96 over 35 meter to the power of 4, which is exactly the same as what we have calculated using horizontal element just now, right? We have noted the answer there. It should be the same. Okay, so that is how you solve if you want to use vertical element for this question for Ix, right? So normally for Ix it's easier to use horizontal, for Iy it's easier to use vertical, right? But if you just want, or if the lecturer choose to become evil and that semester and they choose, let's force the student to use vertical element for Ix, then you have to do all this long calculation. Of course, if that is the question, then normally the time period given to you will be suitable. All right, so but just in case, you have to know both, but for this particular question it doesn't specify the element, you just choose the easiest one, right? In the later question we can see some question actually force you to use certain element just to test your understanding. All right, so with that said, let's go to question number 2. All right, in this question we have the diagram on the left there. You have the curve and there's a shaded area there, and then there's 3-part question here, A, B and C. First, A, determine the moment of inertia of the shaded area about x-axis. Use the horizontal element in your calculation. B, determine the moment of inertia of the shaded area about y-axis. Use the vertical element in your calculation. C, determine the moment of inertia of the shaded area about y-axis. Use the horizontal element in your calculation. Right. So in this question right now, the same diagram, but you have 3 questions where the question actually specify which element you have to use. So this question will test you whether you understand the implication of selecting which element. Right. So you have to follow. But question A says Ix using horizontal. Question B, Iy using vertical. Question C, Iy using horizontal. Right. So we have to solve each of this. So let's go. Let's start with part A, right? So basically the question is the same. Basically you have the area like this. Okay, this is too big, but anyway. And then we have y square 4.5x. Right, and then this is 3. And then this is 2. Okay. So for part A, you need to find Ix using horizontal element. So using horizontal element. So for horizontal element, Ix will be equal to integration of y squared dA. Right? That will be the equation. And then your element will be something like this. Right? So with that element, this will be dy, this will be x. So dA will be x dy. So we need x. So from here, x is, we shift there, so 9/2 y square, right? Or 2/9, sorry. Because 4/5 is 4/5 is 9/2, right? When you bring it there, so it becomes 2/9, right? Okay, so plug in here, so dA becomes 2/9 y square dy. So you are ready to plug in into, okay, I'll just read into this equation here. So Ix becomes integration from where? The limit for this way of element is, the first element is 0, the last element is 3, right? So from 0 to 3. And then y square, and then dA, which is this one, 2/9 y square dy. So basically 0 to 3, you have 2/9 y to the power 4 dy. So you'll have 2/9. So integrate, y becomes to the power 5/5. So you have limit from 0 to 3. So 2/9 times 3 to the power 5 divided by 5. If you calculate this one, 2/9, 3 to the power 5/5, you get 54/5. 54/5 meter to the power 4. That would be your answer, right? So it's as you can see, right? It really doesn't take long, right? Select the element. In this case, you don't need to select because the question already select for you. Horizontal element. This is the equation. You need dA, so find dA, and then solve, right? So it just barely takes, I'm not sure how many minutes, but you can just take a look in the video. It doesn't take that many minutes, right? So that is the answer, right? Going on to part B. Part B, okay, we have to erase this because part B is about Iy. Alright, so part B, we have to find Iy using vertical element, right? So vertical element. So vertical element for Iy equal to integration of x square dA, right? And with that shaded area like that, so you have dx here, and then this is what? Hopefully you have understand this already, right? So because y is here, 3 is there, right? Because this is 3. So it is 3 minus y, right? So with that, dA becomes 3 minus y dx. And what is y? So here we have y square equal to 4/5, 4.5x. Okay. Let's use 9/2. Okay, but it's, okay, let's use this straight, right? So y equal to, we have this square root, so 4.5 power of 1/2, then x power of 1/2. That's square root, right? Okay, let's stick with this one. I don't like decimal point that much in calculation, but anyway, okay, we'll stick this one. But so 3 minus 4.5 to the power of half, and then x to the power of half dx. This is dA. So plug in this equation. So let's use a different color. So you have Iy equal to integration. So from the limit from 0 to, what is this? 2, right? So 0 to 2. 0 to 2. Hopefully you have understood already about integration. If not, just look back at my video, the crash course for integration, right? So you have to understand that. Okay, so then this one is x squared multiply by this dA, the whole thing. So multiply by 3 minus 4.5 to the power of half x to the power of half dx, right? Okay, so 0 to 2, 3x square minus 4.5 power of half x to the power of 5 over 2 dx. So when you integrate this, you'll get 3x cubed over 3 minus 4.5 to the power of half x 7 over 2, so 2 over 7 over here. The limit is from 0 to 2. So this one you can cancel, so you get 2 to the power of 3 minus 4.5 to the power of half times 2 out of 7, and then 2 to the power of 7 over 2. So from here you get, okay, let me check. So from here to power 3, 4.5 half, 2 over 7 to 7 over 2, you will get 8 over 7 meter to the power of 4. Alright, so let's store that, because we have to do another part C where you have to use a different element, right? So we'll store this one first, right? 8 over 7. So 8 over 7 meter to the power of 4. Okay, now we go to part C. We have to erase this one first. So right now what we are doing is the same area, but we have to use horizontal element for IY. So horizontal element, so IY will become integration of DIY, right? So in the lecture video, I have derived this, right? Because, and normally we always already memorize. If you have done enough practice for this kind of shape, you already memorize already. DIY becomes 1 over 3 x cube dy, right? This is from 1 over 3 bh cube or hb cube, right? Which can be derived by parallel access theorem if you don't remember, right? Okay, so x cube, so what is the equation? So y square equal to 4.5x. So x equal to 2 over 9 y square. Right, so plug in here. So okay, so iy is basically integration. In this case, limit is from 0 to 3, right? So 0 to 3. Plug in this one here, 1 over 3. So we have to have x cube, so this whole thing cube. So you have 2 cube over 9 cube, and then y to the power of 6 dy. So straight away integration. So this become, okay, whatever it is, you can calculate your own, right? So y power 7 over 7. So you plug in, oops, you can plug in 0 and 3. So 1 over 3, 2 power of 3, 9 power of 3, and then 3 power of 7 over 7 minus 0, right? So this one equal to 8 over 7 meter 4, which is obviously the same as that one, right? Part B and C is both calculating IY, but using different elements. So you have to know both elements anyway, right? But normally in the question, if you notice, the question that asks for both element is not that long. For example here, right? Just now, in question number 1, to derive that is quite long because of the shape, right? So because this one, the base is the axis itself. So that's why it becomes here. This one is also not that long if you have to derive, right? That is done in the lecture video. Just go back and see the lecture video how to derive this one. It doesn't take long. It just takes less than 5 minutes, right? Okay, so that is the question number 2. Moving on to question number 3. Okay, this is question number 3. So you have the shaded area there in the diagram, and then you have 3 part of question. Question number 1. Determine the moment of inertia of the shaded area about x-axis. Use the vertical element. Second, determine the moment of inertia of the shaded area about y-axis. Use the vertical element as well. Part C. Can you solve the same way, part A and B, if horizontal element are used instead of vertical element? Why? So in this question, basically we have 2 questions which is calculation based. The third question is basically just understanding based, right? So let's move on and straight away answer this one, right? So the first question is Ix using vertical element, right? So basically you have the shape something like this, and then you have to use vertical element, right? So and you need to find Ix. So Ix using vertical element will be integration of dIx, right? So based on this is assuming you are already familiar with this one. So based on Ix equal to 1 over 3 BH cube, so dIx will be 1 over 3 y cube dx, right? So based on that, we can just plug in. But so this equation is x, y equal to 4, right? So because we have here y equal to 4x negative 1 basically, right? Or 4 over x, 4 divided by x, right? So if we plug in here, so meaning Ix is integration of from limit of 1 to 4 here, right? So 1 to 4 and then we plug in, so 1 over 3 y cube, so the whole thing cube, so 4 cube and then x negative 3 then dx. Okay, so ready to integrate, right? So if we integrate this one, so we have 4 power of 3 over 3 here, so becomes x to power of negative 2, so divide by negative 2 here, right? So from 1 to 4. Okay, so if I take all the numbers outside, so what is this? So okay, let that one, leave it be first, over 6, then negative there, right? So we have x power negative 2, right? So basically it will be 4 power of negative 2 minus 1 power of negative 2, right? So based on that, what do you get? Okay, this outside here is negative 32 over 3, negative 32 over 3. That is when you do this one, right? So inside you have 1 over 16 minus 1, right? Okay, so based on that, when you calculate, you'll get 10 meter to the power 4. Okay, so that is basically straight away the answer for part A. What is Ix using vertical element? Is it long? It doesn't take long, right? Okay, next question. What about Iy using vertical element? So the element is the same, however we are now calculating for Iy. So obviously the equation is different, right? So Iy for vertical element, Iy becomes integration of x square dA, right? So I need for dA will be, so this is dx and this is y, so dA will be y dx, right? And y is already 4x negative 1, so basically dA is 4x negative 1 dx, right? So plug into the equation, so Iy equal to integration from 1 to 4 x square dA, which is this one, times 4x negative 1 dx. So you settle this, so it becomes 4x, right? Integrate from 1 to 4 dx, so 4x squared over 2 from 1 to 4, so you get this will become 2, and so you get 4 square minus 1 square, right? So becomes what? 16 the minus 1, 15 times 2, 30, right? 30 meter to the power 4. So that is your answer for IY. Again, another short question. So sometimes the integration question can be quite short as long as you know what to do, right? Short in terms of the time needed, right? Okay, so part C, because we actually solve both part A and B using vertical element, right? The question says, can you use horizontal element in this? Can you solve in the same way, right? So that's basically the question part C. Can you solve in the same way part A and B if the horizontal element used instead? Now, fundamentally, right, because of this region here, right? When you use vertical element like this, you can integrate from the beginning until the end, right? Throughout the region, from the beginning until the end, right? So basically you chop off element like this. Fine. For this one, if you take horizontal element, now this is only valid until here, right? Right? Meaning that you can integrate until here, but here now the region is not governed by this equation of axis anymore, right? So it is only possible if you do composite area, right? Where you divide this into two areas and then label this 1 and 2, and you can still solve to get the same answer, but you cannot solve the same way basically, because the question actually indicate that can you solve in the same way part A and B if the horizontal element are used? Why, right? So that it want to test you whether you understand that. So you can just say you cannot in the same way because the whole region cannot be integrated from the beginning until the end using horizontal. You have to divide into two and use composite area. Something like that give you the full mark for that part, right? Now, just to show, if we are using this one, right? Let's go back to the question part A, right? For Ix, we have shown earlier in this question how to solve using vertical element, right? So if we want to use horizontal element, what will happen for Ix, right? Because for Ix horizontal element, then the equation will be Ix for horizontal will be integration of y squared dA, and we will use this one, right? Hopefully you can see this one. Okay, we'll keep this one and use this one, right? So this one is x y equal to 4, this curve, right? If you use this one and you use composite area, meaning that Ix equal to Ix1 plus Ix2, right? This is composite area. So now this is just for you who have already covered chapter 10, that is the composite area part, right? So if you haven't covered yet, just ignore this one or look it back after you have covered that one, right? So yeah, so we can find Ix1 and Ix2 and you add, it should give you Ix, right? For Ix1, so what is the, because for each of this you have to use this equation here, right? So for curve 1, so Ix1, so that area here will become, this is dy. What is this? It will be x minus, what is this one? 1, right? So x minus 1. That's the length of this element here, right? So dA in this case is x minus 1 dy. What is x? X is 4 y negative 1. Alright, so plug in there here. So you have integration of y square dA. dA is this whole thing. X is 4y minus 1, and then minus 1 here, and then dy, right? The limit will be from, because this one, okay, the limit is here, right, for this region. So it is from 1 to 4. Okay, so from 1 to 4. So what you get is, okay, you expand this one first. So from 1 to 4 integrate. So you have 4y minus y square dy. Okay, integrating, so 4y square over 2 minus y cube over 3 from 1 to 4. So this will become 2, right? 2, and then we plug in 4 first, so 4 square minus 4 to the power of 3 over 3. This whole thing minus, we plug in 1, so 2, then 1 square minus 1 cube over 3. So if you do this, okay, what do you get? 4 square, okay, minus 4 cube over 3 become 32 over 3, and then minus 2, 1, and then 1 over 3 becomes 5 over 3. So this one become, okay, I'm talking too much space. This become 9 meter to the power 4. Right? This is whole thing. What about Ix2? So that's the region down here. So if you take element here, so the length is, what is this length? Because this is 4, right? So the length is 3. This is dy. So dA is 3 dy. Right? So if you plug in there, so integration of y square times 3 dy, right? From what is the limit? From 0 to 1. That's the region, from 0 to 1. So if you integrate this, you have 3y cube over 3 from 0 to 1, right? So this cancel, becomes 1 power of 3, becomes 1 meter to the power 4. Right, so we have individually area 1 and 2. You can plug in here, right? So Ix1 is 9 plus Ix2 is 1. You get 10 meter to the power 4, which should be the same as the answer in part A that we have done earlier in this question, right? So you can double check. So you can still solve using whatever element that you want, but you have to know what how to do it, right? So just now in part A we have solved because the question says using vertical element. You know how to do from the beginning until the end. But if you want, if the question doesn't specify any element, you can use horizontal and combine with the concept of composite area, right? But for this question, there's no reason to do that because it's quite longer than what we have done in part A, right? But anyway, at least you understand. Okay, so that is question 3? So we go into the next question. Alright, this is question number 4. It is very much similar to question number 3, really, right? What is different is just the number, right? So sometimes that is the exam question. We modify question where we just modify certain number. So that is not exactly the same, but if you understand, you understand, right? So, so basically the region is like this. So x, y equal to 5. So this is, this is 5. This is 1 until 5, right? And then the question says, determine the moment of inertia of the shaded area about x-axis. So we need to find Ix, right? So in this question right now, if you understand the previous question, question 3, you know what to do, right? You have two choices, vertical or horizontal. The straightforward way is just use vertical orientation, right? But we will show both so that you understand both and see which one is easier for you, right? But this one is easier, I'm telling you, but regardless. Okay, so if using this one, so it will be integration of dIx. That will be the equation for vertical element, for Ix. So based on this, dIx is 1 over 3 y cube dx, right? And what is y? Y is 5x negative 1. Okay, so plug in here. So Ix equal to integration from 1 to 5 dIx. So 1 over 3 y cube. So this whole thing cube. So you have 5 cube and then x negative 3 and then dx, right? So integrating this, so you have 5 cube over 3. So x become x negative 2, so negative 2 from 1 to 5, right? So if you plug in the values, so you'll get, so if you take all this value outside first, so you get 5 power of 3 over 6, you have negative, and then you have 5 to the power of negative 2 minus 1 to the power of negative 2, right? So you have minus 5 cube over 6, and inside here you have 1 over 25 minus 1, right? So what do you get? So in this case you get 20 meter to the power of 4. So that is the answer for this one, if you use vertical element. Alright, what will happen if you want to use horizontal element, right? So alright, so the same question, but we are using horizontal element, right? So if you want to use horizontal element, then you have to divide the area, become composite area, right? So 1 and 2. And if you want to use horizontal element, right? So because we are finding Ix, so using horizontal is integration of y squared dA. So for area 1, so we have, this is dy, this is, okay, what is this? This is 5, right? This is 5, this is 1. So in this case, it's x minus 1, right? So dA will become x minus 1 dy. And what is x? So xy equal to 5, x equal to 5, y minus 1. Right. So if you want to plug in this thing, dA inside, so Ix equal to integration. So in this case, the limit will be this one, right? So from 1 until 5. So 1 to 5. And then you have y squared. And then you have dA, the whole thing there. So x is this one, 5y minus 1. And then minus 1 here, dy. Okay, so if you resolve this, if you expand this one first, 1 to 5, so 5y minus y square dy. So we have 5y, you integrate 5y square over 2 minus y cube over 3 from 1 to 5. So you'll get 5 over 2 times 5 square minus 5 cube over 3 minus by, when you plug in 1, so 5 over 2 then 1 square minus 1 cube over 3. You get this one, right? So if you calculate this, you will get 1 to 5 over 6 minus 13 over 6 or 56 over 3 meter to the power 4. So this is only for area 1. What about area 2? Okay, we don't have enough space, huh? So area 2, so basically this whole length is 4, and then this is dy, so dA is 4 dy, right? So if you use the same equation, Ix equal to, so the limit is between 0 to 1, right? So integration from 0 to 1, and then you have y square, and then 4 dy, right? So you'll get 4y cube over 3 from 0 to 1, so you'll get 4 over 3. So by composite area, where do you have the area? Okay, so do we have the space? Okay, we have there, right? So Ix is ix1 plus ix2. So ix1 is 56 over 3 plus 4 over 3 becomes 60 over 3 becomes 20 meter to the power 4. So it is the same as you just use for vertical element, right? But of course this again is longer, so why should you do this, right? But you have to know in case the question specify what element to use, right? So that is question number 4, I think, and we'll move straight into question number 5. Now question number 5, you have the diagram there, and determine the moment of inertia about x-axis for the shaded area shown in the figure. Clearly specify the element, which element is used in your calculation. So in this question, I think it's obvious which element that you should use for simplicity. So, and the previous question we have shown how to use both elements. So here I'm just going to show the easiest one, right? So basically you have the region here and you need to find Ix, right? So the easiest one is just use this element, right? There's no reason to make your life harder by using vertical element, right? So if you use this, so Ix equal to integration of y squared dA, and for the element itself, so this is dy, this will be x, right? So dA will be x dy, and from the equation is y equal to 1 over 8 x cubed. Okay, so meaning x is 8 to the power of 1 over 3, y to the power of 1 over 3. Right? Okay, so we can plug in straight away here, right? So Ix becomes integration. So limit is from 0 to 8. So from 0 to 8, so y square times x dy, or these things, right? So 8, 1 over 3, y 1 over 3 dy. So if you continue on, so from 0 to 8, so you have 8 power of 1 over 3, then we have y 7 over 3, right? dy. So if you integrate this one, 8 1 over 3 outside, so this one becomes y 10 over 3. So this becomes 3 over 10 from 0 to 8, right? So this becomes 8 1 over 3 multiplied by 3 over 10, and then 8 to the power of 10 over 3. And then you can solve using calculator, right? So what do you have here? So you get 3072 over 5, or 614.4 meter to the power 4, right? So that will be your answer for this question, right? So yeah, it's quite straightforward if you use horizontal element, right? I'm not sure if there is any reason if you want to use vertical element, but if you really want, you can do it. But in the exam, it's advised just use the simple one to secure the full mark. But if you think, no, I like challenges, I want to do the difficult stuff, up to you. It's your life, your consequences. But if you want to do that, right? Okay, let's try to do that. So the same area, but for whatever reason, maybe you are bored out of your life, so you want to use vertical element there, right? And this is y equal to 1 over 8 x cubed, right? So if you want to use this one, then for Ix is integration of dix, right? And you have to determine what is dix for this element here, for axis like that, right? So for myself, I do not want to repeat the derivation of this, but I have shown it in question number 1. So if you happen to skip question number 1 and you still want to know how this is derived, you go back in question number 1 and see this portion where this is being derived, right? But to cut it short, I just write what we get there, right, after we derive in a long calculation, right? So you'll get the ix equal to 1 over 3 y2 cube minus y1 cube dx. Right, so that is what we have found in question number 1 when we do element like this, when you choose element something like this, right? Okay, so based on that, we just plug in here, right? Of course, this will seem short because we already skipped the derivation, right? So, alright, so after this dix, so we can plug in here, right? So, ix equal to integration, and using this element from 0 to 4, so from 0 to 4, and then you have the ix, this is the whole thing here. So 1 over 3, and then we have y2 cube. y2 is 8, so 8 cube, right? And then minus y1 cube, so minus the whole thing cube, so 1 over 8 cube, x power of 9, and then dx, right? So if you do this, if I take 1 over, okay, so we can integrate straight away, right? So 1 over 3 outside, so 8, integrate this one, become 8 cube x, and then 1 over 8 cube, and then x to the power of 10 over 10, right? So from 0 to 4, that's the limit, right? So what happened here is 1 over 3 is still outside, so 8 cube times 4 minus 1 over 8 cube times 4 to the power of 10 over 10. So if this is correct, so 1 over 3 outside, 8 cube 4, 1 over 8 cube 4 to the power of 10 over 10, then you get 3072 over 5, or 614.4 meter to the power of 4. So it's exactly the same as before, right? So this seems short because we already derived this in question number 1. But if you've done this one from the beginning until the end, it will be quite long, right? But anyway, regardless, the answer will be the same, right? So that's this question. We go to the next question. Okay, this is the final question for this tutorial, question number 6. So we have the diagram there and two parts of the question, part B and C. Part B, determine the moment of inertia for the shaded area about x-axis, and part C, determine the moment of inertia for the shaded area about y-axis, right? So if you have gone through the lecture, you know that part of the factor that of choosing the element is whether we can describe x in terms of y and y in terms of x, right? So if you look at this, right, because basically it's something like this, right? And then it's y square equal to 1 minus 0.5x, right? So that equation here, if you express x in terms of y, it will be x equal to what? 2 minus 2y, is it? 2y square, right? Because if it's 1 minus y square multiplied by 2 minus 2y square, right? While if you want to express y in terms of x, it will be function of x. It'll be quite complex because you have to square root everything, right? So in this case, y equal to this thing, and then y itself, you have to square root the whole thing. Then you can still do, but normally it's a bit more difficult, right? So if this is the case, then the easiest way is to express x in terms of y, and in that case you want to have horizontal element, which will give you dy, right? Hence you will integrate with respect to y, right? So that will be the factor for me, right? So with that said, we will use this element, right? Now for ix, if you are using this element, then integration of x square, integration of y square dA, right? So that will be the equation if you using horizontal element for Ix, right? So if you take out the element, so this will be dy, this will be x, right? dA will be x dy, and x is this whole thing. You can just plug in there. So going here, Ix will be integration of, in this case, what is the limit? It is from -1 to 1, right? So -1 to 1, and then you have y square, and then you have dA, which is x dy. X is this whole thing. So you have 2 minus 2y square dy, right? Expanding this first, so you have integration from -1 to 1. So 2y square minus 2y to power 4 dy. So if you integrate this, you'll get 2y cubed over 3 minus 2y to power 5 over 5. And then it is from -1 to 1, right? So I'm continuing on with a different color. So if you plug in here, plug in 1 first, so you have 2 over 3, 1 power of 3, minus 2 over 5, 1 power of 5. And then minus 2 over 3, negative 1 power of 3, minus 2 over 5, negative 1 power of 5. So what you have is basically 2 over 3 minus 2 over 5, right? So what do you get? 2 over 3 minus 2 over 5 become 4 over 15. 4 over 15. And then minus negative 4 over 15. And then you'll get 8 over 15 meter to the power of 4. That will be your answer, right? Yeah. So it's quite straightforward, right? Some might want to do from 0 to 1 and then they multiply, or they use composite area, right? But you will get the same answer here, right? Because if you use from 0 to 1, you'll get this one, right? Basically this one and this one is just the same. When you add, it just multiple, right? So either way, you still get the same answer, right? So that is for Ix. We are using this one, right? So what about Iy? So we answer part C now. Iy. So Iy using this area will be integration of diy, right? So based on that, based on this area, so diy will be integration, not integration, diy will be 1 over 3 x cubed dy, right? This is being derived. Watch the lecture. I think if you have watched the lecture, I have mentioned about this a lot, right? Where how this come from, and because if you have done enough exercises, this will all become something that you memorize, right? 1 over 3 hb cubed or bh cubed, right? Okay, so plug in here Iy equal to integration from limit, the same limit, -1 to 1, and then you have 1 over 3 x cubed dy, and x is basically this one, right? So of course you have, now you have to expand this one here, right? Okay, so now you just have to expand this. So I need the space, so I'll erase this one. Okay, so with this -1 to 1, so 1 over 3 is outside, so we'll have basically 2 minus 2y square, and then here becomes 4 minus 4, 8y, y square plus 4y to the power of 4, right? And then dy. So we expand further, -1 to 1, 1 over 3. We expand further, so multiply by 2 first, so you get 8 minus 16y square plus 8y to the power 4. And then multiply by minus 2y square, so becomes minus 8y square plus 16y to the power 4 minus 8y to the power 6, and then dx. Oh, it's gone to the light. Okay. Hopefully I didn't make any mistake. So alright, So for this one, basically you'll get integration of -1, 1/3. So I'm simplifying first, so 8. So for y square, you have this and this. So minus 24y square, right? And for y to the power 4, you have 8 and 16, so plus 24y to the power 4. And then minus 8 power of 6 y power 6 dx. Sorry, dy. How come this become dx? This is dy. Dy, right? So you can integrate now. So it will become, so 1/3 is I put outside, so you'll get 8y minus 24y cube over 3 plus 24y to the power 5 over 5 minus 8y to the power 7 over 7. This one all is the limit from -1 to 1. So if you plug in the value, so you get 32 over 35 meter to the power 4, right? So yeah, that will be the answer. Of course, if you want to try to use a vertical element, you can try as well. The answer should be the same, right? So, but I think this video is long enough, and I have to stop anyway. This is too long for recording. So yeah, that's the end of the tutorial for today. We have covered 6 questions. I think by now you should already get a good idea of what you need to understand and what you need to be able to do to be able to solve any type of question in the exam, right? So we have covered quite a number of variation of question that have come in the previous exam question. Hopefully that is very helpful for you to prepare for your own examination, insyaAllah. Wallahu alam. So this will be the end. Do like the video if it has been helpful, insyaAllah. And with that, we see you next time for the next tutorial. Subhanakallahumma bihamdik, ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wassalamu alaikum warahmatullahi wabarakatuh.